Hi there. My name is Tyler Menezes. I'm the Executive Director of Code Day. And today I'm going to talk to you about a skill that your school probably hasn't told you about and may never tell you about. And it's one that you've probably never even thought of. But it's going to play an incredibly important role in your future career as a software developer and in the contributions that we're going to be making to open source. Any ideas what that skill is? It is learning to read code. So you've probably already heard a lot about how you write code. And you've read a lot about how the compiler works, maybe, and if you were to see a simple example of some code, you could probably trace it through as if you were a compiler or an interpreter. You could figure out, okay, like x plus equals 1, that means that x was 0, but now it's 1, so on and so forth. Those really simple cases are probably something you can already do. But when we get into the real world, your first career, your first job, you might be working at a company that has a project that's existed for 10 plus years. And it might have thousands or tens of thousands or hundreds of thousands or even millions of lines of code that have been written that are all part of this project. And someone's going to ask you to make a change to that. Where do you get started? That's where learning how to read code and do it in a sort of a systematic way that doesn't require you to actually understand every single thing that's going on, but sort of helps you break down where the changes you're going to need to make will be made. That's where learning how to read code in that strategic way is going to be important, and that's what we're going to talk about now. Now, we're going to break this down into 3 separate skills that I think are all important for learning how to read code. The first one is reading lines of code. The second skill is reading files and methods. And the third skill is going to be reading, any guesses? It's going to be a code base. All right. Those are the 3 skills that we're going to be talking about. And in this first lesson, we're going to be talking just about how to read lines of code. So just individual pieces of code where it might be a little bit confusing. Now, we're going to get into some code examples that might be a little bit complex. They're probably going to be more complex than anything you've learned in school so far. And this is going to be a real representative example of what's going to happen once you start working on this project. It's going to be difficult to understand what's going on sometimes. That is totally normal and it's totally expected. And I want to just start out by saying explicitly, you can do this. And this applies to absolutely anyone. It is possible for you to learn how to read code that looks very, very complicated. And I'm going to prove it to you. The skills that are involved in reading lines of code are the same skills that you've already developed if you know how to speak any language. Whether it's your first language or a second language, if you can read English, you can probably read code as well, because the skills are very much the same. So let's look at some examples and see how this is going to apply to when we're looking at code. So here's an example. Here's a quote that I pulled. This is from dictionary.com word of the day, right? So you see this quote here. Talking heads on the left and right are fulminating about the labor shortage. Now, most people have probably not seen the definition of the word fulminating before. That's certainly not a word that I had heard before I looked up this, before I specifically went out and looked for words that I didn't know. But take a second to read this quote and see if you can come up with any examples for what the word fulminating might mean. So again, take a second, figure out what you predict the word fulminating might mean. All right, any guesses? I mean, like, that's really what we're doing here is we're guessing, right? We're looking at the context, and we're trying to figure out what this word might mean just from context, right? Or maybe another thing we might do is maybe we've heard a word that sounds kind of like this, And so we know that this other word is kind of related to this one thing, and maybe this word is related to that too, right? I think in this case, fulminating is sort of like angry thinking. That's my interpretation, but I actually don't remember the definition. I know it's something along those lines, but we can figure it out from context, right? We do this every day. You probably are talking to people, at least once a week when they say a word that you don't know, but you can infer what it means from context. Let's take a look at a little bit more of a complicated example. Here's another quote. His malevolence was equaled only by his audacity, and this was, if possible, surpassed by his gasconade. I'm not even sure how to pronounce that. Now, this quote is a lot more complicated. First of all, there's two words here that might be a little bit more, maybe some people haven't heard them. The second thing that is complicated is just the grammar in this is very complex. There's a lot to pack in here, right? This quote has a lot of stuff. But again, I want you to take a few seconds, think about this quote a little bit more, and see if you can come up with a definition for this second word, gasconade. All right, so hopefully you came up with a guess. This one is a little bit more complicated, right? And the skill that we've learned here is not only to infer things from context. So if this just comes up in a book, maybe that word is not super important. You can kind of tell that it's probably something bad. If you know what audacity means, you know that this other thing also probably means something bad, right? But maybe you don't know the exact definition. Now, in some cases, that's going to be totally okay. In other cases, we may need to actually go online and just search for this word and try to figure out what's going on. We may need to put a little bit more time in if it's something that's important to understanding the greater context of this quote. And in this case, I'm not going to make you do that, but it's certainly something that you've probably done in the past as well. As someone says something, you don't know exactly what it means, so you go online and look it up. And this is especially true for maybe like a really technical word, right? If you missed a lecture one day and your professor starts talking about big O notation, and you're like, I don't know what that means, it's very instinctual to go online and do a search and just see if you can figure out roughly what something means. That's another skill as well, is inferring things from context, but also knowing that if you really are not confident, being able to look that up online. So let's take a look at how this applies to learning to read lines of code. So here's some example code that I've written. And you can see that there's some things that you've probably seen before, right? If you take a look at maybe this, this first section up here, that is probably something you've seen before, right? You've seen this, this is a dictionary, and this is an array. And if you haven't seen that, that's okay too. But generally, like, this is the, you can kind of infer even maybe logically what's going on here. Now, this second line of code is probably something that you have not seen before. Oh, hello? There we go. This second line of code right here is probably something that you have not seen before. Or if it does, like, maybe it looks a little bit odd to you, right? You got these parentheses, you got for user, in users. Like, this just looks like weird Python. And the same is going to be true for this third line of code. You probably have not seen anything in here as well. So the skill that we're going to talk about is learning how to search for these things, or try to figure out what they're doing from context. Same as we were doing with language, we're going to do this with lines of code. Now, what we can do when we're talking about lines of code, one of the things that we can do is we can leave ourselves comments, right? We can, and in Python, you do this £, and you can write something next to it. And that's something that we're going to be doing in the code that you're writing. You're going to be leaving yourself a comment about what this does. Same thing for this line of code down here. So we're going to be leaving ourselves comments about what these different lines of code do. So let's see if we can figure this out together. What is this line of code right here? We'll call this line of code number 1. And we'll call this one 2. What does line of code number 1 do? Well, first of all, we can see that clearly the variable itself is called ages. So we're going to think about that context, right? When we were reading a sentence, we had all that context about what the sentence was trying to say. We could tell from context, from the nearby words, what it means. So we can see that this variable is called ages, right? That's probably pretty relevant, right? The variable is called ages. We can also see over here that it's talking about the age of something, right? And we can see that it says for user in users. Now, have you ever seen this for something in something else, right? That's probably some code that you've seen before. You know, for I in range 0, 10, right? Have you ever seen something like that? It's a for loop, right? Now, this looks suspiciously like a for loop. So we can kind of think about, okay, maybe this is something to do with the for loop here, right? And it's something to do with for user and users, so we know who the users are. And then it says user age. So just from context, we can kind of figure out, well, we're probably doing something to do with the age for each user and users. It's kind of like a for loop, right? And we can see that the variable is called ages. And so maybe what we're doing is we're getting the age of each user. So getting age of each user. All right, does that sound pretty reasonable? I put a question mark there because maybe we're not totally sure, and this is something we can come back to and ask about later. This is something that's hard to Google because you don't actually know the term for this, right? You don't know what to Google for. You know, for is going to get you for loops, and that's not what you're looking for either. And it has something to do with these parentheses here, right? So you don't necessarily know what to Google for, which makes it a little bit complicated. So this is something that we could always put a question mark next to, and when we're talking with your mentors later, you can come back and ask them what this is doing if you're not totally confident. In this case, by the way, this is something called list comprehension, and if you know that, it's actually really easy to search for. So this is list comprehension. Easy to search for when you know the term, but you wouldn't necessarily know the term, and that's okay. We put a question mark next to it, we come back and we talk to our mentor, but we have some general idea of what we think is going on. Okay, so what about down here on line 2? What does line 2 do? Well, we're talking about total age here, right? So that's some important context to know. There's this part right here that like we've probably never heard of before, right? Functools.reduce. That's something that we don't know. My guess is you've probably not heard lambda before. But we can go back to things we definitely do know. So we can have some idea of what total age means here, right? A plus B, that seems pretty straightforward. Ages we know from the previous step is probably a list of all of the ages of our users. Maybe, right? So take a second and see if you can figure out what this line of code does from this context and from doing a Google search. So go ahead, go out and do a search on Google if you need to. See if you can figure out maybe what this lambda means or what functools.reduce means, and see from that context if you can figure out, with these things that we've outlined in green that we already know what they are, see if you can figure out what you think this function does. And I'll give you a second to do that, and then we'll come back and see if we can figure it out. All right, so hopefully you were able to come up with at least a prediction of what this does. So how would I have broken this down if I didn't know this already? Well, first of all, I would probably want to know what functools.reduce does. And so this would be my first step. We'll highlight this in red, right? My first step would be to Google this. My second step, and maybe if that doesn't come up with any results, would be to Google this word lambda. And when you're Googling this, because there are so many different programming languages, one thing that's really useful is searching for just Python as well. And one thing that you might need to do is go through a few different search results to figure out what's going on. So let's go ahead and do that now together. I'll go ahead and I will open up a new web browser window. And we will go ahead and pull this up. And let's start out by Googling for Python. Python reduce. Because that was that first function in there. And we can come up with a few different examples up here. And we'll take a look at this and just, you know, we can take a look at some example code can be helpful, or we can just take a look at just the text up here on top. So we can see reduce function is used to apply a particular function passed in to its argument to all of the list elements. Okay, maybe I don't fully understand what that's saying. That's kind of a complicated sentence. So we can come back down here to this example code. And we can take a look at what this example code is saying. And you can see that it's saying we have a list of all these numbers. And it's saying the sum of all the list elements is, and you can take a look, and this code looks a lot like the code that we saw in our thing. So clearly, this is adding all of the list elements together. And then there's some other examples of the maximum of the list elements. Okay, so maybe that's making sense, but maybe not. So we'll go back. You know, if we don't understand what's going on, we can always go back and take a look at another example. So we'll go to this next text. And this looks like more of a tutorial. Tutorials can be really great if you're trying to understand something that is not super, you know, something that's a little bit newer to you. Look at this. This has some example code that shows what's going on. So you can see a plus b, return result, and you know that's kind of what we're passing into it. And you can see reduce, my add numbers. Okay, so maybe we're starting to understand this. Another thing that can sometimes be helpful to me, if I'm trying to understand a concept, like if I'm trying to, this is like kind of a weird concept. It seems like this reduce thing is kind of more of a programming concept than a Python specific method. It seems a little bit more complicated than that. One thing that can be useful is actually trying to search for images. So if we take a look here, we'll go to images, and maybe we'll look for like, here we go. So we take a look at images, and take a look at this. So you can see that we have a bunch of numbers, and we add them together, and then we take this number and add it with the next number in the list, and then we take this number and add it with the next number in the list. Or here's another example, and you can see this is f of x comma y and z. So if you've taken more math classes, maybe this makes a little bit more intuitive sense to you. Here's another image. So this is another way that I think can be pretty helpful sometimes when you're not quite sure what's going on. So in this case, I think what we found out is that what this functools.reduce thing is doing is that it's taking this function over here, which by the way, we didn't Google it, but it seems like this is a function, right? It was talking about how it takes a function. It takes this function here and it runs it for each element of the list. And this function just adds all the elements together. And that makes total sense because that would give us the total age, the total number of all of the years added together. Okay, so we'll go ahead and we will update our note here. So gets all ages added together. And I'll put a question mark there too. Now, what we can do is, again, once this really kicks off and you start working on these projects, you're going to have a mentor. We can take these comments and we can go back with the mentor and we can review them and say, here's what I think this function does. Here's what I think this line of code does. But I'm not totally sure. Can you explain this to me? Can you tell me if I'm on the right track? That is totally okay. That's totally expected. It does not make you look dumb. That is pretty normal for programming. And in fact, you'll see as you get more into programming that the experts in programming often don't know what things are doing either. We may have more experience, and so there are more things that we've come across before, but every single day there are lines of code that we don't know what they do. And to that end, let's take a look at a little bit more complicated example and see how we would break this one down. All right, so here's a much more complicated example of some code. This is from the project Matplotlib, and there's a lot going on here. So we don't necessarily know what any of this does. The comments itself maybe is a little bit useful, but like probably not that useful. It's starting to get pretty complicated here. So let's use this same technique to break down and start to understand what's going on. So we don't really have enough context probably right away to start to understand what any of this is doing. So let's start looking for some things we might Google. So I'm going to start off with this transform. Well, we kind of know what a transform does, right? A transform like changes things. What about this word, non-affine? So let's make ourselves a note. We'll Google this. That is potentially one of the most useful terms to Google, because if we know what the name of a method does, we probably know what the entire method does to some level of detail. And we may need to look into it in more detail, but oftentimes just knowing the name of a method is enough that we're happy to work with it. We don't need to do anything else. Okay, so that's something that we could do. We could take a look maybe at what this transpose function does. There's a theta transformation. This could be interesting. Polar axes is something that maybe would help us understand what this is doing. And there's a bunch more things to do with this theta direction, theta offset. So that's interesting. We get this R origin sort of thing and axes. Well, this is actually helpful. We know what an axis is, right? If we're talking about a graph, we know what an axis is. So this is something we do know. That's good to know. We get an axis over here as well. We probably know what an origin is, right? It's the point where something starts. And we know what a sign is, right? We know a sign is like positive or negative, right? So we have a starting point. We know that this is the positive or negative over here, right? Column stack, I don't know what that does, so that's something else we could potentially look into as well, right? So that's something we could Google. Oh, what about this? Where r is greater than or equal to 0, r or np.nan. Well, depending on whether or not you know what nan means, that might be something you want to Google. In my case, I happen to know that nan means not a number. And I know what the word where means, right? I've used the word where all the time in just colloquial language in my day-to-day life. I use the word where all the time. And we're saying where r is greater than or equal to 0. So we probably know what this line of code does, right? This line of code probably filters r for non-negative numbers, right? That's one line of code we figured out. We still got a lot of other stuff up here. So this is doing something. Maybe we don't care about what these parameters are right now. We know that we're definitely checking first to see if we have an axis. So if the axis is not none, that's something we do know, right? We know that this is checks if axis is set. This line of code right over here seems to have something to do with whether or not some parameter is set, right? So this is some parameter that maybe the user can set, or maybe someone else, right? Like, I don't know where this comes from. We'd probably have to look at more of the code and try to figure out where this comes from. And that's something else we can do, and we'll talk about that in the next lesson. And then we get a bunch of these other things that are going on, right? So now we are starting to get some primitive understanding of what's going on. Let's go back and take a look at what this non-affine might mean, because that sounds like a term that we can Google for. Non-affine. All right, so we got some results here. One thing that I like to do when I'm looking for results as well is I'm usually looking for kind of like a really simple overview. If you've ever gone to like a Wikipedia page, for example, you know what I'm talking about, where like sometimes every once in a while it has like a really good introduction and that's good enough, but most of the time it's like really, really complicated, like hard to understand. I'm looking for the opposite of that. I want the really high level overview. So I'm going to just look through these results and see if any of these look kind of straightforward. And we can also go ahead and go into the images, and maybe the images will have an example for us. Ah, perfect. Take a look at this example. Doesn't this make it perfect sense? It's a little bit hard to see. Let's zoom in a little bit. Look at this. An affine thing seems to modify something in like in a regular sort of linear way, right? Like it takes an axis and it like skews it, for example. But this non-affine thing skews it in an irregular way. So affine seems to be talking about something that is applied in like a really regular way, and non-affine is applied in an irregular way. That's my first guess. Now I'm going to take a look and see if I can find some other examples. All right, so take a look at this. This looks pretty useful. These are non-affine image transformations. You can see these are kind of weird image transformations up here, right? Here's another example of affine transformations. Okay, that's not super helpful. And some of these look kind of complicated. Yeah, and again, you can kind of see like this is transforming everything in a really regular way, and this one's not, right? So I think we've kind of come to an understanding of what non-affine means, which is that this is going to transform something. It's going to modify our, this is matplotlib, so it's probably a plot. It's going to modify our plot in a not perfectly regular way, right? This is going to modify our plot in a complex way. Again, we can take a look and have a question mark there. And if we need to know more details about how it's going to modify it, well, we can take a look at what maybe we'd search for this np.column stack, right? That's kind of the next thing that I would do. Np column stack. We'll go back to, actually, again, Google Image is really coming through for us here, right? 3, 4, 5, 3, 4, 4, 5, 5, 6. 3, 4, 4, 5, 5, 6, maybe? Not totally sure where that's coming from. We can look at some other examples here as well, right? So then we could start to understand what's going on there, and then, then we can start to try to figure out what's going on. So this is a much more complicated example. You will probably not need to do anything quite this complicated here, but I wanted to give you this as an example to show you that this is a really complex piece of code. I'm not a mathematician. I have no idea what half of these words mean off the top of my head, but we can still start to break it down and understand what this block of code is doing. So those are the skills that I really want you to take away when we're talking about reading lines of code. So we'll go back here. We'll do a summary here. So reading. Let me turn my pen so I'm not hitting buttons. Reading lines of code. Right? So one, what context do we understand? Let's, I'll just rewrite that X. There we go. Context do we understand? Those are those things that I highlighted in blue, right? The context are the things that I highlighted in blue. So those are the things like, I highlighted those in green, not blue. So context is going to be in green. There we go. So what context do we know? What are the things that we already understand? So things like the word ages. We know what the word ages mean, right? We kind of have seen something like for user and users before. Or in this one, we saw maybe origin, axis, sign, where, not a number, right? Those are the things we already knew. 2, what can we Google? what are the things that look really unusual and are easy to search for, right? So terms, functions that are being called, just anything that in the code that looks like something that is easy to search for. It's a really unique word. You'll notice, in here, I didn't search for the word for, right? I don't necessarily know what this for user and users thing means, but like searching for the word for is not going to get you anywhere. But searching for the word reduce might get you somewhere, right? So what are the words that we can Google? And again, like we're specifically talking about like easy to search for. Things that are going to have really useful results. And remember with this also sometimes we can, add the word, add like a relevant word. So that could be something like Python. That's the programming language we're using. We'd add Python. We could maybe search for something like Matplotlib. If we were working on Matplotlib, we could always search for the thing that we're talking about in the code and Matplotlib, and maybe they have documentation. So that's another technique you can use for Googling things. And 3, update our understanding. Right? That is comments. Can add our own comments, and those are the things that I put in blue. Now, we're typically not going to commit these comments. It's not going to be something that we're going to want to, we'll want to undo some of those changes before we send this out for community review. But those can be helpful for ourselves. You can put those in the code, or you can make some notes on a piece of paper. That is the basic strategy, and you might need to repeat these, right? You go through this idea, what context do we understand? What can we Google? Leave some comments. Maybe because of those comments, now we understand more of the context. We understand what something else in this code does. So we go back to step 1, and we continue on and on and on and on. That is the basic of reading lines of code. And again, remember, we have this invisible step 4 in this case, which is ask a teammate or mentor. Now, we have limited time. You have limited meetings with your mentor. It's going to be important for you that you don't ask them every question that you could possibly have. Try to figure it out for yourself first. Come up with a prediction of what you think it does and ask if that prediction is correct. Don't just say, I don't understand what this does. You have to come up with a prediction first, and they'll tell you if you're right or wrong. They might not know as well, so your prediction might actually help them wrap their heads around what the line of code is doing as well. But that is a 4th step. If you really don't understand or you're not confident, you can always go to a teammate or a mentor and ask them if they have any idea what this line of code does. All right, so in the next section, we're going to be talking about how we put this together and start to understand larger pieces of a program in the context of like an individual file in a program.